Hi class, we're team 15. Our project is robotics and electronic assembly. Our team is composed of Domingo, Malave, Alex Rosales, and yours truly, Miguel, Verdia. We will discuss briefly why robots are important. And since we're all in a robotics class, that's probably redundant. They do the same work that a human being could do. They do it faster, they do it longer, they could do it, bigger loads, and they don't have any injuries. And especially they don't have any human errors. Some of the applications that robots are used for in today's world are pick-and-place operations, which we'll discuss later. They do high-speed assembly and packaging, and they're also extensively used in the automotive industry for making cars, for putting pieces in cars. And they also used in the food industry for very repetitive motions, which the robots are very good for, as opposed to people. Applications like welding, in which a high degree of accuracy and motion is required, and cleaning and spraying, also used in the automotive industry, and material handling. Here are some of the companies that we do some research on that they have an extensive use of robots, and we're going to talk about specifically about that and what are the products that they have. I would like to point out that our project, since it's a robotic and electronic assembly, and we got a specific type of robot, which is a 2RRP, two revolute joints and a prismatic joint. We're gonna neglect the prismatic joint since we have to do the project representation in a 2D plane. So we're only gonna do the representation of the two arms, the two revolute arms, and we're gonna assume that if we reach those points above the next whatever distance or another plane where the robot needs to work on, the prismatic joint will just go down and reach.
Okay. Our project is based in a SCADA robot. The SCADA stands for Selected Compliance Assembly Robot Arm. So I'm going to explain a little bit how these robots are coming built right now in order to get better accuracy and better development. So they're going with encoders so to take over the step motors. This is for better accuracy in the positions. Applications, specific operational software. Before they used to come designed just to do one unique task. Now, by changing the program, you are going to be able, these companies are going to be able to use the same robot for different tasks just by changing the program in the PLC. They come equipped with a PLC function, which is a processor that is included in these machines. That can hold programs as big as 100 lines, which is a very complex program. Not only you're going to be able to control this machine, this robot, but you're going to be able, by this program, you're going to be able to control the machines around this product. So they come equipped with comms ports. Before you were able to get communication between these machines using a very unique computer, very unique software, hardware. But now they come with comms ports. So with a Windows-based software programming computer, any kind of computer, you're going to be able to get communication between them. Besides that, they come with vision systems. Besides the encoder and the PLC functions, vision system is to get better accuracy and better development throughout his task.
Okay. Those are some of the advantages of SCADA robots. The first one, these kind of robots are fast, they're clean, and they are smart. They have a smaller footprint in their movements. Improves due to the predictability of the cycle times, and also they improve the process flow, the product quality, and the costs. They also reduce the capital cost and increase the manufacturing flexibility. And one of the most important is they're safe. They're safe in the work environment, the people around there, the workers, and they perform the tasks that you want to do. This is basically one of the videos from a dev company. It's one of the manufacturers doing robots here in the United States. This is an example of how fast they move and how precise they move. They do it in an efficient way and in a smart way. They perform different kind of tasks, and they're very efficient. Okay, that's the end of the research process that we did in this kind of field. This is the design part of the project. We create a robot that will perform two tasks. We decided to do this car robot and the first task that we do is to move a chip from a conveyor and to put it in the second conveyor that will be a motherboard waiting for the chip. So the first task basically is move the chip from here, and the second task will be move the second chip to the conveyor to another one. So basically this process will be continuously doing it and assembling the motherboards. So here, in order to create those two tasks, we calculate the path here. This is an example of the table of the X, Y points. Here, this is basically the line of the task 1, where the chip is located here, and you move from there to here, and then the second chip will be here to the motherboard that we place over here. So this is basically the movement of the two links of our robot.
Okay, this graph shows the workspace of our scatter robot. As you can see, we have two circles in here. The big one symbolizes the singular position of our robot. I mean, this is the maximum range that our robot is going to have. But the little one in here is it's not a workspace for a robot because of the kind of mounting that we're using for this robot. In order to take advantage of the whole workspace, we're going to have to, instead of using the floor, we're going to have to mount it from the roof or from top of that robot. But that's what we wanted to explain in this graph. Okay, as you can see, this is a simulation of a robot. You see, it's going through the path that we set up for the whole study of this project. You see, it's going through the path that we picked before and Alex explained before. It's very important to explain that this is a 2RP scatter robot, but we didn't take into account the prismatic joint because of the simplicity of the project. So we took into consideration just the two R's to do our calculations. This is in this graph we try to explain how is the behavior of all the links versus in the first graph, for example, the angular displacement was link number 2 versus time. In this graph, the angular displacement of link number 1 versus time as well. And this one is the angular displacement in between both of the links, number 1 and number 2. And this one is the other one around, the angular displacement between link number 2 versus link number 1.
Okay, here we have the formula for forward position calculations, in which we have an x and a y value, and we plug in certain angles, and we get, we plug in the angles, and we get an x and y. The reason we did this is because in the inverse formula, the program will give us two angles for link 2. It will give us a -30 and 150 since they're complementary. So we try to do it with -30 to see if that was the right approach, and it will give us a shape that we actually didn't want. So we knew that the angle that we needed to take was the second column, which was in this case 150. This is all relative to the ground. They're absolute global angles. In conclusion, we would like to point out that this type of robot is used on the electronic assembly due to the fact that two of the joints are not in the plane of the third joint. So this loads in this part of the robot do not create torques or create forces. They do create, but they don't create motion relative to these two joints. So the application here is a very precise and accuracy. This is extremely important for circuits and chips and things like that are very small. So this is our project. Thank you very much.